All right, everyone, welcome to a behind the scenes stream. So sometimes I will do a behind the scenes, excuse me, just burping up some tea. I will do a behind the scenes stream of my content creation. So I'm making courseware or presentation ware or whatever you want to call it for presentations. So I'm going to make one on Type 5 routes with EVPN VXLAN. I saw a post on Reddit. It was a great post. And it was, what do Type 5 routes do? What are they for? And for EVPN VXLAN, they serve a couple purposes. So I'm going to make a little presentation on what they do. And I'll use my PowerPoint slides here. And I'm going to bring up my Autobox. Right here. So I've been using this environment for quite a while now. And it's a Linux VM that has this, which is VS Code running as a web app. So I can edit files directly on the Linux VM, run Ansible from it, etc. And I've got all these different I've got all these different permutations of different types of EVPN fabrics. For example, we're using a head-end replication. We could use eBGP as the overlay, eBGP as the underlay. I can use ISIS as the underlay. I can use eBGP as the overlay. So there's a lot of combinations that you can do. You can use EVPN all active, MLAG. So this is going to be, get my YouTube's up, make sure that I'm transmitting. GP is the overlay. Okay, that looks good. So I'm going to set up the environment, and first I'm going to document the environment on my PowerPoint deck. So that'll be this right here. So I'll do so whenever I do PowerPoint, I'm a big believer in PowerPoint as a tool, but of course someone wants to just read slides. So the PowerPoint is one of the tools at an instructor's, presenter's disposal. It helps keep everyone grounded in terms of what we're talking about. It's useful for giving diagrams and everything, and I really like it as a tool, but it must be used correctly. And one of the ways that I use it correctly, at least in my opinion, is my PowerPoint template is very simple. Basically, you need a title slide, a section header, and then a couple of variations of some slides, and that's about it. And we want to keep it very simple. So my title slide is going to be Type 5 routes with EVPN VXLAN. And so that's it. That's what we're doing. And the next one is going to be a slide on the topology. This is the example topology. This is also an experiment that I'm doing with having darker backgrounds with lighter text. We want enough contrast that we can read things, of course. Traditionally, most presentations have been black text on lighter backgrounds, and that's generally been a good idea because whenever these slides are shown, they used to be shown on projectors in conference rooms and classrooms and stuff, and on some clapped out projector that says replace bulb since the 1990s. So we wanted as much contrast as we could get from these weak bulbs. So black text on a white background or very light background would be the best way to do it. However, this kind of stuff is not being consumed on in those devices anymore. These are being consumed on screens. So laptop screens, desktop screens, phone screens, TV screens, flat screen TVs in people's living rooms and bedrooms to watch this content. So my thinking is that the darker backgrounds will work better for that, especially if you're watching this late at night. But I don't know. So I'm going to try it this way. A couple of these I've tried it this way. So I'm just doing a very, very generic dark blue background here. So our example topology will be, let's see if I can just cut and paste some stuff. I don't reuse slides all that much, but I do like to reuse diagrams. And so, okay, that's not going to work out really well because the contrast here is terrible. But I copied and pasted it from a white background deck. So I will have to change these colors. So all of these devices, well, first of all, I don't have these two. You know, depending on the quality of your screen, you may not be able to tell I've got something here. So let's do a nice light there, and then our outline will be, let's do that for these two. F4 will redo the last action that you did on the others, which I really like. Outline, we want it to be lighter or darker. Let's do that. Okay, I think that works okay. Or maybe a different fill color. You don't have to be a graphic designer, but you have to know a little bit about like contrast and stuff to make these slides look good. So the fill, do we want to go green? Yeah, we don't want a dark color. Let's go blue. And of course, these should be white because it's a dark background. All right, so that's our environment. And then we've got a couple of hosts. I'm not dual homing them. So I'm just connecting them to one particular leaf or another. Oh yeah, I need to zhuzh up the lines. So what do we want for a line color? I'm thinking, yeah, it's nice and bright. Can't mistake that. I'll lighten this up a little bit too. And the outline here will be there we go. Okay. Not terribly happy with these colors, but they'll do for now. So this is spine. Ooh. So yeah, definitely need to change the default there. Spine 1. Make sure these are all black text. Spine 2. Spine 3. Leaf 1. Leaf 2. And leaf 3. And leaf 4. And this is host 1. Host 2. I'll put their IP addresses and MAC addresses in there too. So I need this to be a little bit longer. And this to be a little bit longer. I like that there's that automatic thing that shows the width that matches another object, which is nice. So 10, 1, 10, 100, and then 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1. And I'll put these two in monospace font. Shrink them down a little bit. And shrink these down. $12, good. Okay, so we've got the relevant information. So this is our example EVPN VXLAN topology. So the question is, what is a type 5 route? 5 route. Or what are the EVPN route types? So we'll go ahead and change the layout to being the content. So type 1. EVPN is an address family for MP-BGP, multi-protocol BGP. There are several route types. Depending on the information being conveyed, being shared. So type 1 route, EVPN type 1, is ESI auto discovery, I think. Let's go ahead and go. This is the research part. EVPN route types. It's giving me a chat-like or AI large language model. Type 1 and 4. They're a little bit confusing. That'll be probably a different video. Let's go for. Let's look at the IETF. Let's go straight to the route types here. That's Ethernet segment. It's handled a little differently in VXLAN. So that I think it was MPLS. It's hard keeping track of them. And there's all sorts of different. Fun fact, NVGRE used to be a way that you could encapsulate EVP and VXLAN. I mean, it still is, but no one supports it anymore. The initial war, what we would call the initial overlay wars, NVGRE was one of the competitors trying to muscle out VXLAN. It never worked. I mean, it worked, but it never won. Let's see which one of these has the route types. Type 2. Nope, doesn't have that in there. Integrated routing and bridging. Oh, RT5. Yeah, this is probably it. I just want the route type. So sometimes you get stuck on the thing you're not even trying to like. Not even trying to. There we go. Well, we'll just use the definition that Arista uses in the actual product itself. So there's a command we can run, show BGP EVPN route type, and then you can, it'll tell you, so this is Ethernet auto discovery. EVPN type 2 route is endpoint reachability. MAC and MAC IP. EVPN type 3 is IMET inclusive multicast Ethernet tag. I think that's what the acronym is. Let's check it out. Yeah, all of the different the EVPN VXLAN is not just one standard. There's actually a bunch of them, and they are all adopted at different times. It's a little confusing. I don't know which ones are which, really, other than a vague notion of what they all do. I'll just say it's used to determine which VTEPs need flood frames in head-end replication. Type 4 and EVPN type 5 IP network route. So 1 and 4, I always get confused what they do. Ethernet segment route. So 1 and 4 are both used for EVPN all active. I think, God, I can't remember. I think one of them is used to discover the other nodes, because when you have EVPN all active, one of them has to become the designated BUM forwarder. Because unlike MLAG, which BUM frames, so broadcast, unknown, unicast, multicast, will go down both links or all links in the port channel in the lag. With EVPN all active, there's no way to determine. So the flood frames go to every VTEP. Every VTEP would then send the same flood frames down to the host. That would, if you had 4 links, you would get 4 times the flood frames. If you had 5 links, you get 5 times the flood frames. So by one of these is used to determine which one is the designated forwarder. So the other ones will not send any multicast, broadcast, or unicast. It will only send the broadcast or unknown unicast rather. It will only send the known unicast. So the type 5 network route. So let's see here, type 5 network route. I know what it does, but sometimes I just want to make sure that I'm describing it correctly with what, because every now and then when you're an instructor and you've got a lot of knowledge and you forget a lot of knowledge, the real definition of something can kind of shift in your head to being something not quite accurate. A great example of this that a lot of people make, a mistake a lot of people make, and it was one I made, is how to describe LACP. If someone says to you, LACP will divide traffic across multiple links, they are wrong. That is not what LACP does. That's what link aggregation does. And a lot of people mix up LACP and link aggregation. They say LACP, but what they really mean is link aggregation. So I've made this mistake before. What LACP does, by the way, is all it does, the only thing it does, is determine which links are eligible in a given lag port channel. That's it. It does nothing else. Anyway, so known as IP prefix route, used to advertise IP prefixes. Okay. IP prefix route. And it's used internal and external networks. Think of a type 2 route. Well, let's do this. I'm going to do this. Difference between type 2 and type 5. So type 2 route is used to advertise endpoint reachability. So either a single MAC address and then a single IP host address. Either a /32 for IPv4 or /128 for IPv6. So it's a host address. There's no subnet to it. Type 5 route is used to advertise network prefixes, anything larger than a /32 or a /128. So that's what the difference is. Why do we have them? So a type 5 route, an EVPN VXLAN, is used, an EVPN type 5 route is used externally, used for internal subnets as well as internal subnet reachability, as well as external subnet reachability. So an EVPN type 5 route is used for internal subnet reachability as well as external subnet reachability. And then I'm going to give examples of both. So internal reachability information is necessary for silent hosts. Silent host discovery in EVPN VXLAN, in symmetric IRB. I don't think it's needed for asymmetric IRB. I'm going to test that in a second here. For external reachability, a border leaf will connect to an outside router and learn external routes. Type 5 routes will disseminate that information to the other leafs. So we need it for silent hosts internally, and we needed it to learn connected. We'll connect it outside route. We need it for silent hosts, and we need it for disseminate, propagate. I don't know if I like the word disseminate or propagate better. More TASMR. So that's what they do. So let's go to our diagram here. That's what it is in a... I wonder if this background should be darker to make the contrast a little bit better. You can edit the format the background. So that's the lightest color. So I want to just get rid of these entirely. Yeah, they don't really do anything. All right, so that and that. Let's try that. Just a little bit darker for the background, just to make things pop a little bit better. Kind of liking that. We'll see. All right, so here's our topology. Example EVPN VXLAN topology. We've got to highlight some things. I want to put this in the background. And I want this to be light but transparent. Oh, that's the line. I don't care about the line. I want the fill. Fill to be transparent. And I'm going to put the text at the top. This is ASN 65. So what I'm doing is I'm showing that this is eBGP. This will go at the bottom. I'll send that to the back. It's 101, 102. I'll send them all to the back in a second here. 3 and 4. Drag these down a little bit lower. That's kind of annoying because now I have to get rid of this because it changed. But I can subtract this stuff pretty easily. All right, so then I want to try to center that, center that, center that. And then I need to distribute these evenly. And then recenter. Also, I want to make these smaller, so I will copy, slim them down. Center them. So that's one aspect of them. Let's go ahead and do another aspect. What do I need to demonstrate? Oh, I need to demonstrate the forwarding tables. So I need a diagram that shows the forwarding tables. And this is for symmetric IRB. And I need a logical diagram. So the logical diagram is pretty simple to draw. I've got a L3 VNI slash VRF called blue. So I'll make that bright blue. And then I'm going to have two, I'll make them yellow. I tend to use yellow for VNIs. I don't know why. Maybe that's a little bit of synesthesia. Synesthesia. Oops, I didn't mean to do that. That is a little bright. And there's a high contrast only. That's interesting. I don't need to go that far. I think there is a way that I can shape fill more colors. I just need to dull it down a little bit so it's not so bright. Yeah, that's a little bit better. All right. This will be an L2 VNI, VLAN 10. L2 VNI 10,010 VLAN 10. VNI 10,020 VLAN 20. There's an IRB interface, Anycast gateway. It's going to be 10.1, 10.1. So this is symmetric IRB. Just so people know what we're dealing with here. And connect them like this. Not like that. Nice bright color for this. Yeah, we'll do that. Okay. So this is the logical diagram. We're using symmetric IRB. I might try to show this with asymmetric IRB, but asymmetric IRB is really rare. I don't really see it that often. I don't think Arista even really teaches it. It just mentions it, but it never teaches you how to configure it in their level 3 course. It's actually easy to it's easy to configure, but it's actually more work to configure it than symmetric IRB. Okay, so here's our logical diagram, and then we need forwarding tables. So I'm going to have two switches, and they're going to be the shape fill is going to be the same. Whatever that is, that powder blue. Is that what I used? Gonna keep this stuff straight. I think that's what I did. Yeah. So this will be leaf 1. And put that at the bottom. Make it a little bit bigger, but it's... And leaf 4. So we only have hosts connected to leaf 1 and leaf 4 for now. So we just need those tables. We need we need 2 tables. Actually, we need 2 tables apiece. So I'm going to shrink this way down. So 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1. Did I do 0, 1? Let's do 0A. Then 0B. And we'll do a monospace font for that. I like GitLab. It's my preferred monospace font. This needs to be smaller. It's always a trade-off between readability and how much real estate on the screen it takes up. Ethernet 10. So that's connected on Ethernet 10. So here I'm going to delete, or I'm going to table design. If I highlight these 2, I can, table layout, I can merge the cells. There we go. So this is the layer 2 forwarding table, Mac VRF, VLAN 10. Let's go ahead and delete these rows. I can add more later if I need them. Then we have, there's a layer 3 forwarding table, IPVRF blue. Copy and paste this over here. Oh yeah, I'm gonna need another row below and another row below here because we're gonna learn each other's. I'm gonna do an animation. I think I can do an animation here. Unless I want to do just progressing through slides. So I'm showing what happens with type 2 routes, how we propagate those tables. So I can show why we need a type 5 route when something doesn't work. So can I do an appear? So animations. Some people don't like animations in PowerPoint. They can be tricky. They can be very useful, but they have to be used correctly. Transitions, however, have no place in PowerPoint, and you should never, ever do transitions. I freaking hate transitions. I have dealt with so many slides. When I used to, fun time story, I used to do a lot of Cisco classes, and I never worked for Cisco, but I worked a lot with Cisco for the various products. So I was a CCSI, which is their instructor certification, but I never really taught many official courses. What I taught was sales training courses. And it was actually a very good idea. Like, let's say you're a company and you're looking at a new blade system, and you're looking at Cisco UCS, and you're looking at HP, and you're looking at Dell, and these are complex systems. So they would get the marketing fluff from the other vendors, whereas Cisco would say, come join us for a free 2-day course, and we're going to teach you about Cisco UCS, so you can make an informed choice. And it was it was called a test drive, and it was a fantastic sales tool, and it worked out quite well. But the problem is that I wasn't dealing with the engineers oftentimes. I was dealing with the marketing departments, and most of them were pretty good. Most of them were fantastic. But a few of them would have these like weird ideas in their head of what they wanted the PowerPoint deck to look like. One included like a 100 gig photo in the deck. 100 gigs. It was like some TIFF that they couldn't figure out how to convert into like a JPEG. And they're like, oh, the JPEG doesn't have high enough quality. So they were insistent. And it wasn't even part of the deck. It was like a transition slide from one section to another section. And it kept crashing PowerPoint. So through the class, PowerPoint would crash because it had this huge... anyway. Or they would do transitions. And sometimes marketing people... I don't want to disparage marketing as a profession because it is important. But sometimes people concentrate on the wrong things in marketing, just like anything else. Anyway, so this is the story of what happens when you plug a host in. So the first thing that happens is we have to see some traffic. So let's say we do see some traffic. We learn the MAC address. So that would be an animation. That would be an appear or fade in. No, darn it. I wanted the text. Just the text. Can I just do the text? What about that? Nope. Crap. So that means I've got to put it into its own object. That's a pain. And then X that out. So that would be an appear or fade in. All right, so we learned that. Okay. So that also will yeah, it doesn't do anything to this table. A type 2 route is generated. So if you're watching this just to see how I do the process, that's fine. I will be making this into a presentation. It will be much shorter. So we're 40 minutes into this, and I'm 9 slides in, which is about pretty normal. But you'll be able to watch the presentation when it's complete. So if you don't want to watch me, if you don't want to watch the plant-based sausage being made, then you can wait for the presentation, which I'll probably record today. This shouldn't be a very long presentation. Okay, so X out that, create a new thing, make that smaller. That's on leaf 1. Okay, do. All right, I'm going to grab some tea and hit the restroom real quick. Be right back. I have been re-teed. All right, so we learn a host, we learn the local MAC address, we put it in the local layer 2 table. This is VLAN 20. And what happens is 2 different types of routes get made, 2 different type 2 routes, 2 type 2 routes. You know, these should be different for, let's do... Table design. This should be a different color. Do I want to do... Let's do orange for that. I want to show that there are different types of routes. Or I should match... I should match what I did here. So this is going to be a blue and blue, and then this will be a yellow. Except there is no yellow. I'll do purple. These, and then I should match these. Trying to be consistent to convey the same information. It's one of the tools you can do when you're doing this kind of stuff to make things consistent. All right. What color should this be? Let's make this a yellow since I got rid of yellow. Ooh, that is low contrast. There we go. So type 2, and it's the MAC address. There's a second one that is MAC IP. They both get generated, they both move over. So both of these, do I want to do a table to convey them? Let's try that. Then I'll merge these cells. So in center, type 2 MAC route. I could merge these cells too. No, I want to do this. Because it's the MAC field. Make it green. Yeah, like this. We'll do this. Need one more below, and one more below. Actually, that was not what we wanted. There we go. So 2 of these routes get generated. So when that MAC learning event happens, these are going to appear. So this is an animation, fade in, and then they're going to move. Shoot, I didn't. Oh, animations. They can be very useful. So these are fade in, or they appear. And they should. All right. And we'll do fly in. No, we don't want that. That is terrible. Fade. They fade in. Then we add an animation. That's move. Need my certification for PowerPoint here. So I think that works. Show up, move. There we go. And then we also have these two. So they also have an appear, but we move them ahead. There we go. So host sends a frame to leaf 1. We learn its MAC address. That generates two different type 2 routes. They get sent over to leaf 4. Now they disappear. So I'm going to add an animation after. And that is for them to disappear because they need to go away. And show that it inserts these two in. And this doesn't have anything to do with anything right now. Oh, yeah. Then if that works, let's get rid of these. Yeah, I think that'll be it. So here's the presentation. Get rid of these. So let's say a host 1 communicates with the fabric in any way. It doesn't really matter. So what will happen is the local MAC learning will occur just like it does on any normal switch, but it will also generate two type 2 routes for symmetric IRB. One is the MAC route and one is the MAC IP route that's used to populate the ARP tables of the remote IRB interfaces. So they get propagated. So they end up over on leaf 4 in this case. And what will happen is it'll get inserted into the local routing table. So now if host 2 wants to send a packet to, oh, I've got the IP address wrong here. This should be 10.100. So now we have the forwarding table populated with the host route for host 1. So if we want to send a packet to 10.1.10.100, we know exactly where to send it. So leaf 4's routing table is fully populated, or at least populated enough that host 2 could connect to it. But what if host 1 wanted to ping host 2? Here's where the type 5 route comes in. Host 2 has enough information to talk to, well, let's say, yeah, let's go ahead and make a new deck. We'll call this silent host. And the table is empty. So host 1 doesn't know, it sends a packet to 10.1.20.200. There's not enough information with just the type 2 routes to populate this. Let's do another one where there is enough. So the local MAC address is learned, and we know where that's at for the MAC address, but that also would trigger the same type of route type. So now we have these symmetric routes. So host 1 wants to send a packet to host 2. It goes up to the routing table, goes to the default gateway because it's not in the same subnet. We look into the VRF routing table, and we see that we have a host route specifically for 10.1.20.200. So it sends a packet over and then delivers it locally in same back and forth. So we have the populated tables, so we have enough information to send traffic between the two. But what if we have a silent host? So host 2 has not communicated. I need to just realized I'm missing something. So host 2 hasn't communicated. It's a silent host, or maybe it did communicate, but it hasn't communicated in a while. So the MAC address got expired, got withdrawn, and then that withdrew all the type 2 routes in the fabric. So the fabric has no idea where to send packets. We should do another packet here. What color should I make that? We'll do that. Okay. I'll go ahead and move. We'll do an appear. Animations. Appear. Add animation. Lines. No problem. And then add animation is disappear. So here's what it looks like. So I have enough information to send the packet to where it needs to go. And the packet can come back because there's enough information for that to come back. So do I want to do I want to do a new object. No animations. Flip them. And then I want to, I do want to do animations here. So I want it to fade in. I want it to move. And I want it to fade out after. So it looks like this. So packet comes into the leaf. We populate its MAC address. We generate the type 2 routes. We populate all the tables. Actually, you know what? I'm just going to make... Yeah, just make them pre-populated. So here we got populated tables. So the MAC addresses don't really matter in this case because it's subnet to subnet. Packet comes in, the source address is 10.1.10.100, destination IP address is 10.1.20.200. We do have a match in the table. Maybe I should put in a, yeah, I should do a match. I should highlight the match. So that'll be, so the way I like to highlight things is I do a 0 fill, red outline, and I make it at least a weight of 3. And then I'll do the same thing over here to match that we have a match in the forwarding table. And then I'll draw a line between them, also bright red. Also 3. Also bright red. There we go. So I need this to appear and disappear. So in animations, they're going to appear. And then they're going to disappear. So the appear is going to happen right after. Yeah, right before there. The disappear will happen before the move. Packet, we match, disappear, packet moves. Perfect. Reciprocal packet also has a match. All right, I think that's a good way. That's a good way for the animation to work. Now we have the silent host. So here's the whole point about the type 5 routes is we have an IP packet. Get rid of all the other. Packet comes in. Where do we send it? We don't have a match. So I'm going to copy this. Paste it. Oh, that's not what I wanted to copy. This, this, and this. Copy. Paste. And then put in also just to show that we have no idea what to do with it. So normally, or traditional, so for traditional IP routing for silent hosts, can we get rid of the MAC address? Because we don't care about the MAC address here. I can make the text a little bigger for readability. Stretch them out a little bit. There we go. to their match. There we go. Get rid of, oh, yeah. Just want to get rid of the animations. Then I need a routing table. Give us some room here. There we go. So that's the network, and that's the next hop. Over here, just copy and paste this. And I'll put something to show that that is the next hop. This is the these are actually the IP addresses I tend to use for this demonstration. Okay, so the packet would go, if we're going to do animations. The other way to do it is just do steps, and we can do a step table. So let's move this over here, and we'll do a step table. That table will be over here. So step one is packet sent from host to R1. Step two, lookup occurs and packet is forwarded to R2 via 10.151. So that's step two. This avoids have to do animations. I'm already sick of doing animations. Step three, R2 has no R2 ARPs for host's MAC address to see if any host answers for 10.1 2200. 4 is host 2 responds ARP. ARP reply. And then we have the EVPN VXLAN challenge. We have a leaf. And there are going to be a huge number of other VTEPs. I love distribute horizontally, or vertically in this case. 3, 4, 5, 6. So what comes up is, what in the heck? So the problem comes that we don't know which of these leaves have that subnet instantiated. That's why we need the type 5 route. Because if we get a packet and the leaf does not have an entry in the forwarding table, what are we going to do? Because there's a bunch of leaves. Maybe there's 2 more leaves, or maybe there's 200 more leaves. We don't know where to send it to try to get that router to ARP for it. So here, if we don't know what the host is, it's okay, because the packet just gets delivered to the router that has that local subnet, and then it will ARP on that subnet. Here, all of those routers, remember, we're doing an Anycast gateway, and they some of them might have 10.1.21. But not all of them may have it. So how do we know which one to send it to? So that's where a type 5 route comes in. So type 5 route. Let's go ahead and do this. So they generate a type 5 route. Where's my type 2 routes that I generated? So type 5, IP prefix. Now, it doesn't actually say leaf 1. It says the VTEP address of leaf 1, but I'm just going to put leaf 1 Actually, this is leaf 1 here, so that can't be leaf 1 right there. 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, and 7. So now leaf 1 has the information it needs. Oh yeah, it populates the table this way. Because it'll actually show up in the VRF routing table. So 10, 1, 20, 0, 24. Shows up as leaf 2, leaf 3, leaf 6. So it's ECMP. Then when we go ARP, then we get 10, 1, 20, 200 / 32. Oh yeah, these should be moved to leaf 4 because that actually is on leaf 4. There we go. So I will copy and paste. There, and they're going to appear because we did the ARP. So that's why we have. So here's the explanation. And this is for the internal reason. So I'll do a new slide here. Section header, type 5 use internally. And now we get to the external reason, which is a little bit simpler to explain. Type 5 routes are generated when a leaf connects to an external network and knows routes to the outside. Those routes are propagated by the type 5 route to the other leaves. This is how it works in ACI too. When we learn on a border leaf. So also a border leaf, there's not really a distinction between a border leaf and any other type of leaf. It's just a label we give something. It doesn't necessarily have any, it could be the same kind of leaf. You can use a border leaf for other purposes too. You just call it a leaf. And so I'm going to grab this diagram here. And we'll do external routed connection. Actually, I do need those. this up a little bit. Move that out of the way a little bit. Move that out of the way a little bit. Because I'm going to plug a router. This will be R1. And unplug that into leaf 3. And it'll be BGP, so we're going to exchange BGP routes. And R1 is going to be plugged into a network. That's not what I wanted. I wanted the cloud. Where's the cloud? There it is. 72.16.0.0. So that's 12. So that is connected to R1. Really, I'm just spoofing an address in there. And then that is connected to a host. And 72.16.0.10. We'll do fill. And we'll do black. There we go. Host external 1. Okay. So here we've learned on leaf 3 forwarding table, we know that 116.0.0.12 next hop is going to be 10.1.5.0.1. Yeah. We know 10.1.10.100/32 is on leaf 4. And we'll do one more row. So row above, 10.1.20, 10.1.10.100, leaf 1, 10.1.20.200 is on leaf 4. Make that a bit bigger. Make sure we know that is nice and big. So what I'll do here to highlight this, give a little bit of contrast, I'm going to see if I can do any kind of like, no, I can't really. There we go. There we go. A nice way to highlight leaf 3 that we're looking at leaf 3s. Again, it's all about contrast. And then we look at leaf 1's forwarding table. And we don't have our own. We don't have the other one. So it's looking kind of empty. How do we get... So how do we get that layer 3 forwarding table? So this leaf 1's table. Okay. Just checking something real quick. All right. And that's where the type 5 routes come in. So remember the type 5 route prefix. Let's do this. Copy. Then I will populate the tables, and I think that'll wrap it up. We're just about done. Oh, this type, it's 172.16.0.0.12. So I make a thing here. GitLab mono. 172.16.0.0.12. Send that to leaf 3. Yep, that'll do it. And we'll just have these appear. So this will appear first. Fade in. And then fade in. All right. I think that's it. That 18 slides. Took me an hour and a half. That's pretty normal. So let's do some math. How long does it take me to do a slide? So 18 slides, 19 slides, very complex slides. So 90 minutes divided by 18. So 5 minutes a slide. That's not bad for slide generation. Pretty pleased with this. So I'm going to stop this, and then I'm going to record me doing the presentation. Oh, actually, before I stop this, I'm going to set up the lab environment so I can do a demo of this. So, because I'm going to, as I'm doing the slides, I'm going to walk through all the different configurations. So, let me just see where we're at on this environment. Show interface, show IP interface brief, show LDP neighbor. So I'm plugged into Ethernet 4, or I'm sorry, Ethernet 2 and leaf 4. And one more thing I want to do in Ethernet 2. This is really cool. Interface Ethernet 2. I'm going to make my MAC address 0000000001, or 2 rather. Oh yeah, it's... So that way in the fabric, my MAC address will show up as that instead of some random MAC address. So this makes it a lot easier to track things as they go through the system. And I'll do the same thing on host 1. Show IP interface brief. Just on Ethernet 1, that looks good. And then show run Ethernet 1. MAC address router. Okay. Now let's see what the leafs are like. So the underlay looks good. Show BGP EVPN summary. Overlay is good. And then show run section BGP. What do we have configured? So it's symmetric IRB. I can tell because asymmetric IRB has no learning. There's a command under VLAN 20. All right, so leaf 1 does not have VLAN 10. Oh, it should have VLAN 10. What the heck? It shouldn't have VLAN 20. Crud. All right, so, and then there's endpoint connect. All right, I'm going to regenerate. I'm going to have to regenerate the configs or redeploy them. Playbooks, deploy, HER, EBGP, all active. So this is erasing the existing config. Source git. I don't know what that is. Okay, I'll have to figure that out later. I should own everything. I'll accept CLab admins, but that should be fine. If one show run section BGP. All right, so I have to. What I'm going to do is manually prune VLAN 20 out of leaf 1 and 2 and VLAN 10 out of leaf 3 and 4 so that it's I don't have every VLAN everywhere. It's because I want to be able to demonstrate this. RBGP. Oh yeah, I want to do no VLAN 20. No interface VLAN 20. Show run interface VXLAN 1. Interface VXLAN 1. No VXLAN VLAN 20. And then router BGP. Take the no VLAN 20. So taking the MAC VRF out of there. So show run section BGP. All right. And then leaf 2, got to do the same thing. No VLAN 20, no interface VLAN 20, VXLAN 1, no VXLAN VLAN 20, VNI 1020, and router BGP, no VLAN 20. Removing it from the there we go. Leaf 3, no VLAN 10, no interface VLAN 10, router or interface VXLAN 1, no VXLAN VLAN 10 VNI 2010, router BGP. This is why we do automation. This is just a small change in an environment that's changing quite a lot, so it's not a big deal. But if I had to do this on a big fabric, I would hate myself. No VLAN 10, no interface VLAN 10, no show interface E12, show run interface E12. Okay, that's good. Interface VXLAN 1, no VXLAN VLAN 10, VNI 10,010, router BGP, no VLAN 10. Just VLAN 20. Okay. So now this conforms to the setup here. And I think I'm ready to do the recording. So I'll probably record it live because that's the easiest way to do it. And if the quality is good enough, I'll just publish it. So if you're sticking around and you want to watch this happen, I can show you the presentation in just a few minutes. But I'm going to be about 5 minutes. I'm going to go to the bathroom, make some more tea, and get a little snacky snack.